Hello friends. So in this video we are going to discuss about pair of linear equation in two variables. Right. So this is one of the chapter in NCERT mathematics book for class 10th. So we are going to expand upon this particular topic, and then we are also going to solve some problems. Now before going any deeper into this chapter, we will first discuss what is a linear equation in two variables. Right. So how is it represented? So I can represent a linear equation in two variables as this, where not both a and b are 0. So either of them can be 0 but not both of them. So there is another way to represent this condition, like if not both a and b are 0, can be represented as a square plus b square is not equal to 0. Now you understand why, right? Because if they both are not 0, then for non-zero a and b, this cannot hold true. So a square plus b square cannot be 0, because this is a positive number, this is a positive number always, and the sum of two positive number is always greater than 0. The only case when a square plus b square will be 0 is when both a and b are 0. So if I have to represent that both a and b should not be 0, then this is the condition that I can represent it with, right? So this is the form of linear equation in two variables. Now if I ask that how can we represent real world scenarios with a linear equation, so where does it get application? So let's say there is a boy named Robin who went to a fruit seller. He bought 3 bananas and 4 apples, right? So he bought 3 bananas and 4 apples, and he paid a total of 24 rupees, right? So how can we represent this as an equation, as an algebraic equation, right? So we can say that assume that the price of banana is rupees x, and similarly we'll assume the price for one apple is rupees y. So then price for 3 bananas would be 3x, and price for 4 apples will be 4y. And since Robin paid a total of 24 rupees, so we can say that 3x plus 4y equal to 24, right? Because this is the price that he paid for banana, this is the price he paid for apple, so the total price will be the summation of them, and then this equation can be formed. So 3x plus 4y is 24. Now this is in the same form, right? This form. So we can write it as 3x plus 4y minus 24 equal to 0. So this is how we can represent a simple situations in the real life situations in algebraic equation or other linear equation. Okay. Now the next thing is that can we, so let's say a question asked you that determine the price for one banana and one apple. So the question is, with this information, with this equation, can we find what is the price of banana or what is the price of apple? We cannot, right? Because this is an equation in two variables, but only we are only given one equation, but we have two variables, so we cannot solve it uniquely. So there can be infinite number of solution for this particular problem. For example, if my if let's say the price of apple was 1, then what will be the price of, if let's say the price of banana was 1, so I can substitute 1 here, and my y will be 24 minus 3 by 4, which is 21 by 4. So this is one solution. If the price of banana was 2, then again I can solve this equation by putting 2 in place of x, which will give me 24 minus 6 by 4, which is 18 by 4. And similarly, I can solve it for x equal to 3, x equal to 4, x equal to 5, and each time I will get another solution. So this particular one equation in two variable will never have a unique solution. It will have infinite number of solutions. We can also see this graphically. So let's first understand how a linear equation in two variable is represented in graph. So what do we get if we try to plot a linear equation on two dimension, which is xy coordinate? So my linear equation is in the form ax plus by plus c equal to 0. So how does this look on graph if I try to plot it, right? So let's say we'll take a simple example. Let's say we'll say that if my equation was x equal to y, right? So this is also a linear equation in two variable because it is x minus y equal to 0. So in this case, a is 1, b is minus 1, and c is 0. So this is also a linear equation in two variable. So how can we represent that in our coordinate system, right? So let's say this is my y-axis, this is my x-axis, this is y-axis. So let's say x. Okay. So I have to represent this in the graph. So when does this hold true? If I have x equal to 0, my y equal to 0. So uh, uh, if x is 0, then y is 0. So the first point that I get is this 0, 0, right? If x is 1, y is 1. So the next point I'll get is here. If x is 2, y is 2. Sorry. So I'll get the point as here. Similarly for x3, y3, I'll get a point somewhere here, right? And if I try to plot this, connect this dots together, I will get a straight line, right? So the equation x equal to y is a straight line. So that gives us the hint that a linear equation in two variable will be a straight line when plotted on the x and y coordinate. Similarly, we can take another example. We can say, let's say x is equal to 2y, which is nothing but x minus 2y equal to 0. So if we try to plot this, how can we plot this? So again, if I take x is 0, if I take, let's say, y equal to 0, so my x is 0. So my first point is here again. Next I take y equal to 1. So for y equal to 1, x is 2, right? For y equal to 1. So for y equal to 1, my x is 2. So my next point is here. For y equal to 2, x is 4. So for y equal to 2, x is 4. And similarly, we can have other points also plotted. And if I again try to connect these things, this will be a straight line, right? So any linear equation when plotted on the xy coordinate will give us a, a straight line, right? So that's how we can plot a particular equation. Now when I said that any linear equation in two variable will have infinite number of solution, it won't have a unique solution, and that can be visualized by this graph also. So a solution for a linear equation is the value of x and the value of x and y that solves that particular equation, right? And that value is nothing but the point that lies on that particular line. So if I represent ax plus by plus c as a line, straight line on the graph, any point that lies on that particular line is a solution to that equation. For example, for this equation, x minus y equal to 0, this was my line, and any point that lies on this line like 0 0 1 1 2 2 3 3 or 0 0.5 0 0.5 is a solution to this equation. So it can have infinitely large number of solutions, because this straight line has no bounds. It can go from minus infinity to plus infinity. Similarly, for this equation, we have 1 2 as one point which lies on this line. We have 2 4, we have 3 6, we have 4 8. So all this pair of coordinates or all these points lie on this straight line. So all of them are a solution to this particular linear equation. So that's why we cannot, so if, given our question that we knew that this is the equation, but we cannot determine what is the price for banana or apple just based on this equation. To solve it, to get to a unique solution, we need at least one equation, one more equation to get a unique value of x and y, right? So that's the motive of this chapter, that we have a pair of linear equation in two variables to get a unique solution for that particular scenario. So let's take this question in another form. So we also already know that Robin paid a total of 24 rupees for 3 bananas and 4 apples. So let me add another situation to it. Let's say Shyam also went to the same shopkeeper and he bought 4 bananas and 6 apples, and he paid a total of 34 rupees, right? So to represent that equation, I can say, okay, a price per banana is x, so total price paid for banana is 4x. Price per apple is y, so total price paid for apple is 6y. So my total price paid for both the fruits by Shyam is 34 rupees, right? Now we have two equations, one for Robin and one for Shyam, and now the question requires us to find the price for apple and banana. So how can we find that? So again, if before going into solving this equation, I want you all to visualize this problem. What do we mean by a unique solution? When we already saw that this individually has infinite number of solution, and all the solution are the points that lie on this particular line, so the solution are all the xy coordinates that lie on this particular line. Similarly, this particular equation will also have infinite number of solution, and each of the solution is actually a xy coordinate which lies on a line represented by this equation. So when we say that solve these two equations together, what we are actually asking? We are actually asking for a xy pair or xy value, xy coordinate that lies on both of these lines. Then only it will be a solution to both of this equation. And what does that mean? That means that we are trying to find a intersection point for these two particular lines, because that is the only point that is going to lie on both of these lines. right? So if I have a xy coordinate and I have one line here and one line here, so this is my line 1 and this is my line 2. There are lots of points that lie on this particular line. There are lots of points that lie on this particular line, but there is only one point that is lying on both of these lines, and that is the intersecting point, right? So this point, if represented by xy as the coordinate, is a solution to the equations represented by L1 and L2. So in order to get a solution for these two linear equations, we have to find the intersection point of these two lines. That is the graphical way of solving this. Later we'll also see the algebraic method of solving this, but the graphical method is always very intuitive to understand. So let's try to plot these two equations on the xy coordinate. So I have already plotted it. I'll just go through it. So this is my y-axis and this is my x-axis. So for this equation, if I, as we already discussed, to plot this equation on this xy coordinate, what I can do, I can find the x-intercept and the y-intercept. So we have already discussed about this in the just a little while ago, that my intercepts are 0, 6 and 8, 0. So this particular line represents 3x plus 4y equal to 24, right? And for this line, if I have to get the x-intercept, I need to put y as 0. So if I put y as 0, my x-intercept will be 34 by 4, which is 8.5. So this is the point, right? 8.5 and 0. And to get the y-intercept, we have to put x as 0. So our y will be 34 by 6, which is 5 plus 4 by 6, which is 5 plus 2 by 3, which is 5.666, right? So I have approximated it as 5.7. So this is my point and this is my point. So if I connect these 2 points together, this particular line represents 4x plus 6y equal to 34. Now these two line intersects at this point, and this is my solution for this equation. So this will be, if we can also see it by calculating or simply putting some values here by hit and trial method, and see that which point actually solves these two equations, or when you are plotting it accurately on a graph paper, this will give you the solution, right? So the solution well calculated is actually, so I have x as 4 and y as 3. So 4, 3 is the solution. Now since this is not an accurate graph, we cannot count the coordinates and see. So that's why I had pre-computed it, and I know that 4, 3 is the solution. We can also verify by putting it here. 3 into 4 is 12, 4 into 3 is 12, that is 24, and 4 into 4 is 16, and 6 into 3 is 18, and 18 plus 16 is 34. If you plot this correctly on the graph, you'll get 4, 3 as the intersecting point, right? So this is how we can solve a pair of linear equation in two variables by plotting them onto a graph. So uh, do we always so if I ask you that will we always get a unique solution if I am given two linear equations in two variables? Will it always be the case that I'm able to find a unique solution? So you can pause and think about it. Yeah, so we cannot say that two linear equations into variable will always yield us a single unique solution. We will only get a unique solution when the two lines represented by the equations are intersecting, but that might not be the case always, right? So in this case we saw that they're intersecting, that's why we got a unique point of intersection. But what if, so let's say this is my xy coordinate, so what if these two lines are parallel? So if they both are parallel, are they going to intersect anytime? No, right? So if they're not going to intersect, they're not going to yield us any solution. Similarly, we can also have a situation where we have coincident line. So let's say this was my line, and then we have another line which is coincident to this line. That means overlapping to this line. In this case, we'll again have infinitely large number of solutions, because every point on each of the line actually lies on both of the lines, right? Because they are nothing but coincident lines. So we have three different cases. This is our case one, when the lines are intersecting and we know that we'll get a unique solution. We have a case two, where the lines are not intersecting, they're parallel, and we know that it is not going to yield us any solution. And there is another solution, another problem, or another situation where the lines are coincident, and we know that we are going to get infinitely large number of solutions. So these are the three cases. Now can we quickly look at the equation and tell whether it is going to give us the unique solution or infinite solution or no solution at all? We can, and we'll discuss that now. So suppose we have a pair of equation, linear equation, represented as, so if we have to find whether we are going to get a unique solution for these pair of equations, or we are going to get an infinite number of solution, or we are going to get no solutions at all, we need to find whether these two lines are intersecting or they are parallel or incident, right? So there are two ways of doing it. You can either plot these two equations on a graph on the xy coordinate, and then find out whether they are intersecting or they are coincident or they are parallel. Otherwise, we can look at these coefficients, and then we have a handy way of knowing whether they are intersecting or not. So if a1 upon a2 is not equal to b1 upon b2, that means lines are intersecting. Okay. If a1 upon a2 is equal to b1 upon b2, we know that these two lines are parallel, but uh, those two lines can be parallel like this, or we can also say that the coincident lines are also parallel, but they are coincident. So to get these two different situations, so for both of these situations, a1 upon a2 has to be equal to b1 upon b2. But let's say if it is equal to c1 upon c2, that means lines are coincident. And if I have a1 upon a2 equal to b1 upon b2, which is not equal to c1 upon c2, that means lines are parallel. So in this case we are going to get a unique solution. In this case we are going to get infinite solution, and in this case we are going to get no solution. Okay, so this is a unique solution. So this is how you can quickly check the first you have to get your equation in this form, and then you can check whether the lines are going to yield a unique solution or not, right? So so we have till now discussed the graphical way of solving these equations by plotting them on a graph, and then getting the intersecting point to get the solution. So if in the questions where you are asked to plot these particular equations, you can plot them on the graph, and then also you can see the intersecting point. You can obtain the intersecting point and then obtain the solution. But that is not always the case. That will not be always the case. Rather, it will always be possible. So we will have to uh, also know about the algebraic method of solving these equations. So when we don't have graphs handy, we need to know the algebraic methods of uh, solving these equations, right? So now we'll see the algebraic method. So there are 2-3 methods that we'll see today, which can be used to solve this problem. So we'll now discuss. Okay, so the first method that we are going to discuss is called substitution method. Okay, so the first method we are going to discuss is substitution. So let's take the same example that we have been discussing, which is 3x plus 4y equal to 24, and 4x plus 6y equal to 34. Now we have to solve these two equations with algebraic methods, and we are going to discuss the substitution method here. So what substitution method tells us is that you get the value of one of the variable in form of the other variable with one equation from one equation, and then substitute that into the other equation so that it becomes a equation of one variable. So we all know that one equation of one variable will give us a unique solution. So we have one equation, and we only have to find one variable, then that is going to yield us a unique solution. So what we need to do is, since the first equation is in terms of x and y, we need to get a relationship. We need to get the value of x in terms of y, or y in terms of x, and then substitute that in the next equation. So let's say if I get x in terms of y, so what it is, so my 3x is 24 minus 4y, so my x will be 24 minus 4y by 3. Now we got the value of x in terms of y. If we substitute this x in this equation, So we'll replace x with this value. We are only going we will only left with a variable y in this equation, which can easily be solved to get the value of y. So let's substitute the value of x, which is 24 minus 4y by 3 plus 6y equal to 34. So now the problem reduces to solving this particular equation to get the value of y. So this will be, if I multiply 24 by 4, it is 96 minus 16y by 3 plus 6y equal to 34. So I'll start from here. So this is 96 minus 16y plus 18y upon 3 equal to 34, which is 2y plus 96 equal to 34 into 3 is 102, 12 and 102. So 2y is 102 minus 96, which is 6. So y is equal to 3. So we got the value of y, and now we have to get the value of x. So we can get the value of x by putting y in any of these equations, right? And that will give us the value of x, or we can get the value of x from here. So we have already deduced that x is 24 minus 4y by 3. So which is 24 minus 4 into 3 by 3, which is 24 minus 12 by 3, which is 12 by 3. So x is equal to 4. So our solution is x equal to 4, y equal to 3. Right? So this is one of the method of solving this. Now this was also the method, this was also the value that we would have got when we would have solved it graphically. But this is one of the way that we can solve it using one of the algebraic method. So the second algebraic method is called elimination method. So in elimination method, uh, we try to eliminate one variable uh, by multiplying or dividing one of the equations with a number, so that we so the second method that we are going to discuss is the elimination method. So in elimination method, uh, we will try to eliminate one of the two variables and then solve for the other variable. So again we'll take the same example. So these are the two equations, and by elimination we mean that we somehow need to make the coefficient of either x or y same in both these equations, so that we can cancel them out, and then we can solve for another equation. So in this case, let's say we have to eliminate x. So we have to make the coefficient of both of these equal, so that we can subtract this equation from this equation and cancel out the x value altogether, so that we are only left with y. So what we can do, we can multiply this by 4, the entire equation, and we can multiply the entire equation by 3, right? So this will get us 12x plus 16y equal to 96, and 12x plus 18y equal to 102, right? Now I see, I'll say that I will subtract this equation from this equation. So I can say I can subtract this, right? And I'll get, so this will be cancelled out, right? So I'll get minus 2y equal to minus 6, and the minus minus will be cancelled out, and that will give y as 6 by 2, which is 3, right? And once I get a y as 3, I can put it in this equation, like 3x plus 4 into 3 is 12 equal to 24. So 3x is 12 and x is 4. So again we got a solution as 4 and 3 by using the elimination method. Also, there are some cases in which the equations that are given do not seem to be a linear equation in the first look, but they can be reduced or converted to a linear equation into variables, right? So for example, if let's say I had equation, right? So let's say this is the equation. Now looking at this, it does not follow ax plus by equal to c or any of that format, but we can simply convert it into a linear equation, because we see that this is nothing but, right? So in this case, 1 upon x is the variable, 1 upon y is the second variable. Instead of x and y, 1 upon x is the variable. So we can say that, okay, if I take 1 upon x as another variable, let's say p, so this will be converted into 2p plus 3q equal to 13. Similarly, the other one will be 5p minus 4q equal to minus 2, and then I can solve this equation. So I can again take any of the algebraic method to solve this problem. So let's go with the method of elimination. So what we'll do, we'll have to make any of the variables coefficient equal in both the cases. So let's say we may try to make the equation the coefficient of q as the same. So we'll multiply this by 3 by 4, and multiply this by 3 to get 12 at both the cases. So we get 8p plus 12q equal to 52, and 15p minus 12q equal to minus 6, right? So these will be cancelled out if we add them together, and we get 23p equal to 46, which gives us p equal to 2. So since p is equal to 2, that means 1 upon x equal to 2, which means x equal to 1 upon 2. Now we can put this value, p's value, in one of the equation. So let's say I put it in the first equation. So I get 4 plus 3q equal to 13. So 3q equal to 9 and q equal to 3, which means 1 by y equal to 3, which means y is 1 upon 3, right? So my solution for this problem is x is 1 by 2 and y is 1 by 3, right? So this is not a very straightforward. While looking at the equation, you would feel that this is not a straightforward linear equation. But then you can, with some analysis, you can convert it to be a linear equation. Right? We can take another example. So I'm taking all these examples from NCERT book. So we have 5 upon x minus 1 plus 1 upon y minus 2 equal to 2, and 6 upon x minus 1 minus 3 upon y minus 2 equal to 1. So again, in this case, this looks a little complex, but we can see that in this case our variables are 1 upon x minus 1 and 1 upon y minus 2, right? And if we take this as p and take this as q, this will simply be 5p plus q equal to 2 and 6p minus 3q equal to 1. And then we can solve this equation with any of the two algebraic methods to get the answer. So let's solve it with substitution method. So I get q is 2 minus 5p from the equation 1, and I'll put that into the second equation. So 6p minus 3, 2 minus 5p is equal to 1, which is 6p minus 6 plus 15p equal to 1, which is 15 plus 6 is 21p equal to 7, which gives us p equal to 1 by 3. Now since p is equal to 1 by 3, we know that 1 upon x minus 1 is 1 by 3, right? So x minus 1 is 3 and x is 4. So we did a cross multiplication here, right? So x minus 1 is 3, so x equal to 4. Similarly, we can put this p's value in this particular equation. So our q will be 2 minus 5 by 3, which is 1 by 3 again, right? So 1 upon y minus 2 equal to 1 by 3. So y minus 2 is 3 and y is 5. So uh, our answer is x is 4 and y is 5. So I hope this was clear to you. You are now clear with what linear equations are, what are the different ways of solving them, what are the way, how can we solve them graphically, how can we solve them using algebraic method, and how can we reduce the not so obvious linear equations into linear equations by just doing some analysis and then converting them uh, to a linear equation. So I'll solve the exercises in another video that will follow this video, and you can also post any comment on this video if you don't understand any of the concept discussed here, or if you want a particular question to be discussed. If I am not able to discuss all of the exercise questions, you can also post them in the comment section so that we can discuss it in any of the later sections. Now subscribe to this channel, like this video, so that you'll get all the videos that I'll be releasing for the mathematics or the science chapters. Thank you very much for your time.